So we'll be looking at simultaneous equations using the substitution method. In the last video, we looked at the elimination method, where we actually eliminated one of the variables. So to have one variable in the equation, and then we solve for that variable. And after finding the value of that variable that is left, we substituted or plugged that value into one of the equations to find the other variable that was eliminated. And so substitution will actually bring some similarities in actually solving simultaneous equation, but it is somewhat it is not 100% similar to the elimination method. So let us look at what is really substitution method. So the substitution method is all about taking having after while when you have when you have a pair of simultaneous equations, you actually take one of the equations and you're going to rearrange one of the equations to make one of the variables the subject. After doing that, then you're going to substitute that variable into, let's say, one of the other equations. And then you'll have, after doing that, then you'll have just one variable in the equation. And after having one variable in the equation, we're going to just simplify the equation. And then we're just going to make the variable that is the only variable in the equation the subject, or find the value of it. After finding the value of it, then we will just revisit one of the other equations to find the value of the variable that we made the subject in the inception of everything. But let us do an example to see what exactly is substitution and how does it work. Well, let me write an equation. So if I have x plus 7y is equal to 64 plus, well, x plus 3y is equal to 28. Now we could rewrite or rearrange any one of these equations to make one of the variables the subject. It doesn't matter if you use equation 1 or equation 2. Both equations seem pretty much easy to use. So I feel I will just work with equation 1. So let us leave our equations. So equation 1, equation 2. So I'm going to take equation 1 and rewrite it. So we have, well, x plus 7y is equal to 64. And now what I'm going to do, I am going to make x the subject of this equation. I'm going to make x the subject of this equation. So we can have x all by itself, and then we just plug that value into one of the equations. So let us make x the subject. So if I make x the subject, I would have to get rid of 7y. It's a positive 7y, so we will subtract both sides by 7y. And that cancels that, leaving us with say x is equal to 64 minus 7y. And this is actually the jackpot of this equation. So after having the value of after making x a subject, now what we're going to do is to take this value now, which is actually equal to this, and we're going to plug it into, well, we're going to, so we use equation 1, so we're going to plug it into equation 2. Well, you could actually plug it into equation 1 if you want, but we don't want that. We just want to export all the equations. So let's plug it into equation 2. So anywhere we see x in equation 2, we are going to substitute it for this. And that's why it is called substitution. We're going to substitute it. So let us say 3x plus 3y is equal to 28. Let us bring it out a bit further. Let me see. I hope you can see this is not too small for you. Alright, so what we're going to do is just plug it. Let me change my color to, let's say, purple. So anywhere we see x in the equation, we're going to substitute 64 minus 7y. And so we have now 64 minus 7y. 64 minus 7y plus 3y is equal to 28. And now if you should examine this equation now, we just have only one variable in it. And that is always the objective. Whether you're using the elimination method or the substitution method, the aim is to have one variable in the equation. Because when you have one variable in the equation, it is so easy to solve. And that's what we always want. So this looks like well, it is a simultaneous equation is a linear equation. So when you look at this looks like a regular linear equation that we will actually solve. So what we will do is to group the like terms. So let's simplify the equation. So we're at 64, and we say you owe 7y's at the shop. You have 3y's in your pocket. So you will have negative 4y is equal to 28. And so we will just make y the subject. So what we have to do is to subtract both the sides by 64. We subtract because to get rid of the 64, we have to apply the opposite term of 64, which is a negative, and that it gives us 0. And now 0, if when we cancel these two, it gives us 0. So we say 0 minus 4y gives us back 4y. And if we should subtract, negative, if you owe $64 and you have $28 in your pocket, you will be owing $36. And so we can just make y the subject by solving for the value of y. And then we'll actually divide both sides by 4. Because of the 4 is being multiplied by the y, so we have to use the opposite operation of multiplication, which is division. So we cancel that, and this will give us y will equal to positive 9. Negative cancel negative, 436 goes 9 times. So now, 9 times. So the thing is now, after finding one of the variables, no, this is so easy because this is what we want. This is like using the elimination method. After getting rid of one of the variables and having one of the variable in the equation and solving for that variable, then we just take this one and plug it into any one of these equations that we want. We could use any one of these equations. Well, as a matter of fact, we could plug this into equation 1 or equation 2. It doesn't matter which one you want to plug it into. But since we use equation 2 to solve for y, we are going to use equation 1 to plug it into plug y into equation 1, which is x plus 7y equal to 64. It doesn't matter, as I say, you could actually plug it into equation 2. It doesn't matter because the value of y is basically the same thing in each equation. It doesn't matter. It won't change anything. So let's look at equation 1. So this is equation 1. So we're going to use this equation. We could even work it out on this side. So we say x plus, so anywhere we see y we plug 9. That's the value of y. So we have 7 times 9 is equal to 64. And so we say for this, we say it's equal to that. We say that this was 63 equal to 64. So we just make x a subject by subtracting both sides by 63. That cancels. So x is equal to 1. And we could actually prove that this is so. We could actually say, we could actually use any one of the equations again to find out if these variables are what we got for them. So we could use equation 1 or equation 2 to evaluate our variables to see if these variables actually have the right answer. So let us use any one of the equations and to find out. So if I should choose equation 2 to prove if x and y are actually what they say they are, let's substitute. Anywhere we see x, we put 1 plus. So using equation 2 to prove it, you could use equation 1. As I said, it doesn't matter which one you want to choose. So we could say, okay, all right, 3, what is the y? Y is 9. Let us work this out. If we have 1 plus 3, 9 is 27. And 1 plus 27 is actually 28. So we prove that he's right. We get 28. We could actually use equation 1 to find out if this is true. Let us use equation 1 also. We could use it to see if x is actually equal to 1 and y is actually equal to 9. We could say x, anywhere we see x, we put 1 plus 7. And we have 9. And let us see if this is equal to 64. So 7 nines gives us what? 63. 1 plus 63 gives us 64. And so we actually prove it. So we prove it that these variables are indeed correct. Let's look at another example. Very, very, very simple to use. Very, very, very simple. Very, very simple. Let's look at 4x minus 4y is equal to 24 x minus let's say 4y 3. Now the thing is that you could use substitution method to solve a pair of equation that seem as if you could use the elimination to solve. Because we could use elimination to solve this. We could go ahead with elimination method and solve this, because if you're looking at this carefully and what we learned in using the elimination method, when you have two identical terms in the equation, we could just you could actually subtract these and you get 0, and the y values will be eliminated, and then we just have x all by itself. We just have just x only in the equation, and once you have one variable in the equation, that will be so useful to us, or for us to actually solve for the variable. But substitution method can be used in either way, in any way. Substitution method can be used in a situation where you will apply elimination. But elimination cannot apply in a situation where you probably could use substitution. So the substitution one is more universal than the elimination method. So let us continue with the substitution method. So we want to arrange one of these equations so we can actually have one of the variables being the subject, and then we substitute it into the other equation, then we simplify and find the value of that one variable that we are seeing in the equation. So equation 2 seems, you could use any one of the equations, but equation 2 seems a little bit easier to actually rewrite or rearrange to have one of the variables the subject. So we'll say we'll actually work with equation 2, and in this case we'll actually make x the subject, because x is easier to be the subject than having y being the subject. So we can actually just add both sides by 4y, and that cancels that, and so x will be equal to 3 plus 4y, and that's the objective, having one of the variables being equal to something in terms of the other variable. So we can plug it into one of the equations and just get rid of one of the variables, and just get rid of one of the variables that are in the equation and just have only one like term variable, just one. So we're going to take the value of x and plug it into equation 2. And so we just have one equation with only one variable, because that is always the objective. Right, so let's see. So we have now, anywhere we see x, we will plug in, let me see, what's the value of x again? 3 plus 4y is the value of x. So we have 3 plus 4y, right? And we have minus 4y is equal to 24. So we'll be going up. So we will distribute the 4 to each term in the bracket. So we have 4 times 3 gives us 12. 4 times 4y gives us 16y equal, no, minus 4y equal to 24. And so we have one variable in the equation. That's always the objective. And so we can just go ahead and simplify this and find the value of y. So let's group like terms. So we write back 12, and we say 4 from, we have, so you owe $4 at the shop, and you have $16 in your pocket. You could actually use that in that example. So we have positive, let's say, what's that? Say 12 is equal to 24. You will subtract both sides by 12. That cancels that, leaving us with, let's say, we say y is equal to these two will give us just 12. And we could actually make y the subject, cancelling both sides by that. And so y would be equal to 1. So if y is equal to 1, no, we can just use we could use one of these equations and solve for x. So it doesn't matter which one of the equations that you want to use. I could actually use equation 2 if I want, because it seems easier to use. So I could actually use equation 2 if I want, because it looks very easier to use than using equation 1. So we can use equation 2. Right, so anywhere we see y, we will substitute and replace 1. So let's rewrite that. So we could say for x, what's equation 2 again? Let's look at equation 2. So equation 2 is x minus 4y is equal to 3. So let's go. X minus 4y is equal to 3. Now, what is the value of y? Y is 1. So anywhere we see y, we put 1 equal this, equal to 3. So we have x minus 4 is equal to 3, making x a subject. So we add both sides by 4. And then we have x is equal to 7. So when y is equal to 1, x is equal to 7. So when y is equal to 1, is equal to 7. And this is also a point on a graph where we say x is actually 7 and this is equal to 1. If you should actually graph these equations, you'll actually see that these two lines, because a linear equation is just a straight line. It's a straight line that you actually plug in values into the equation and find y. So actually, because when you look at the linear equation, because simultaneous equations are linear equations. And if you remember what we look at in linear equation, where you have we have a variable in the equation, which is x. It could be any other variable, but in terms of the y and the x-axis, then we actually use x and y. And so you plug in some values into the equation for x, and you get the outputs which are the y values. And so you could actually see a straight line being constructed, and then since it is two equations, you see them intersect. They will intersect, and where they intersect, that this point will tell us where they actually meet. But we're not doing anything graphically, but we just simple solving the values for x and y in this simultaneous equation. But we could prove if our variables are correct. Let us see if 7 is let us see if x is actually 7 and 1 and y is actually 1. We could actually use any one of the equations to prove it. So let's look at our equations that we have. So these are the equations that we have. We could actually try to see if these are, if our values are correct. We could use any one of these equations. So if I choose to use equation 2 to see, to verify if my values x and y are actually right. Let's see. If x is 7, let's just say 4 times 7 minus 4, and y was 1. Let us see if this gives us 24. 4, 7 is 28. And 1 times negative 4 is negative 1. 4 from 28 gives us 24. So indeed, our answer is correct. So that's it for substitution. That's it for substitution. You can actually remember substitution is just trying. You're actually arranging one of the equations that seem easy to rewrite or to make a variable the subject. After arriving at that, then you just take that variable that gives you the variable that you actually made the subject, plug it into one of the equations, and then you just cancel that variable and just only have one variable in the equation. And once you have one variable in the equation, we could just simplify the equation by grouping the like terms and simplify and make this one variable, this new one variable as a subject. And then when we find a value of that, you get a finite value. After getting the finite value, then you plug it into any one of the equation to get the variable that you actually made the subject from the beginning of the process. And there you go, having the values of x and y. And remember, it doesn't have to be x and y. It could be any other variables. But if you're using like the graphs, we have x and y on the graph. So we actually use x and y. But there you go, substitution. And I hope this video will help you a lot. So if you like this video, you could like, share, subscribe, and leave your comment so I can see what you are actually thinking or how you feel, or if you have any other requests, then I will actually make myself available for that request.